Past year questions. This video we shall discuss about the mechanic 2023 October November paper 41. So let's take a look at the first questions. We have a mass of particle of mass 1.6 kg projected up with a speed of 20 meter per second up an inclined plane. The plane is smooth and inclined with the alpha to the horizontal, where tangent alpha is 43. So usually when we see tangent alpha is a 4 over 3, not 43, I'm sorry, 4 over 3. So this is a 3 here, this is a 4 here, this is a 5. So we can make use of a Pythagoras theorem to form this triangle so that it's easier for us to find sine alpha or cos alpha later. Okay, so now the question wants you to use the conservation of energy to calculate the distance travel. Okay, so distance travel, that means this is the h, this is the height, then this is the distance that you travel. They want to know the x. Okay, so what is the relationship between h and x? So you know that h over x is a sine alpha. But sine alpha, you refer the sine alpha here. Sine alpha over here, it will be 3 over 5. That will give you the h is a 3 over 5x. Okay, then by using the conservations of energy, we have the PE loss, PE gain, sorry, is equal to KE loss. So you have a mgh is equal to the half m of the u square minus a v square. But because they say that it come to instantaneous rest, so we know that the v is a 0. We know that the v is a 0. So over here, you can cancel the m, and you will get the u square is equal to the 2gh. So what is a u? U is a 20, sorry. The g is a 10. The h is over here, 3 over 5x. So you just press a calculator, the 2 and 10, the 20 can cancel. So your x is actually 100 over 3 meter. Okay, done. This will be the answer for the question number 1. Now we move on to question number 2. Mass 2.4 kg held in equilibrium by 2 light inextensible string, one of which is attached to the point A and another one is attached to the point B. The string makes an angle 35 degree and 40 degree with the horizontal. I refer to the diagram over here. Find the tension in each string. In each string, yes, correct. Okay, so how are we going to find the tensions over here? So you can redraw again the diagram. This is your weight. That will be 24 Newton. This is a 40 degree. This is a 35 degree. This is your tension A. This is your tension B. This is the vertical. Okay. So now, if you resolve the forces vertically, so you get the TA sine 30. TA sine 35 plus the TB sine 40 is equal to the 24 Newton. Okay, that will be my equation number 1. I don't plan to press a calculator for these two values. I just leave it like this so that I will remain the answer as accurate as possible. So now if I resolve the forces horizontally, I get TA cos 35 is equal to the TB cos 40. So you can either make the TA in terms of TB or you can make the TB in terms of TA. So over here, I think I will make the TB in terms of TA. So it will be, sorry, this one is 40. So it will be TB is equal to the TA cos 35 divided by cos 40. I call this one equation 2. Again, I don't plan to press a calculator for this value. I just remain as it is. Looks a bit troublesome, but I try to make it the value as accurate as possible. Okay, so now you put 2 into 1. Just solve the simultaneous equations. You have a dA sine 35 plus the dB. Now the dB already replace it with dA cos 35 cos 40 multiplied by sine 40 equal to 24. So now if you can factorize the dA out, then over here you get sine 35 plus the cos 35. I would like to combine these two, become tangent 40. Okay, so now after I have this, now I can find the dA. So actually just press a calculator. Okay. So I just press a calculator over here and then bring it over here to divide. So this one you can press it yourself. I press it directly. So the answer will be 19.0 Newton. Correct to 3 significant figure. So I replace it back to the I replace this value into the second equation, put it back here. Then I can find my dB. So it will be, again, you press a calculator, your dB will be the 20.4. Also 3 significant figure. Okay, so this will be the answer for the number 2. And move on. We have question number 3. We have a graph over here. The diagram shows the velocity against time graph for the motion of a bus. The bus starts from rest and accelerates uniformly for 8 seconds until it reaches the speed of 12.6 meters per second. The bus maintains this speed for 40 seconds. It then decelerates uniformly to 2 stages. Okay, so these 2 stages is the decelerations. Then decelerate between 48 to 62 seconds. The bus decelerate at A. Okay, so decelerate at A. Per second square. And between 62 and 70 seconds, decelerate 2 meter per second. So you know that the deceleration and acceleration for the VT graph is the gradient. Okay, so we need to find the gradient. So we have 3 points over here. So we can call this one V. So this point will be called 48, 12.6. This point will be called for 62 and V. This point will be called 70 and 0. Okay, so between 48 to 60, between 48 to 60, 62. Sorry, I didn't read the question carefully. The question part A is actually asking us to find the distance covered by the first 8 seconds. So we only want to know the distance over here. Okay, so distance is the area. So the distance traveled, the distance over here is actually half times the base times the height. Press the calculator, then you will get the answer 50.4 meter, just like that. Okay, then the B, they want to find the value A. So like what I mentioned just now, I need to use a gradient. Okay, so this gradient, the time frame of 48 seconds to 62 seconds. Okay, so the gradient is the V minus what is the formula for gradient? Y2 minus Y1 over X2 minus X1. So V minus 12.6 divided by 62 minus 48. Okay, but they mentioned this is a decelerations. Okay, so the question mentioned that the A is a deceleration, so you're supposed to put negative in front. Okay, yeah, there's a negative in front here. So remember, the gradient itself already negative. The gradient itself is already negative, but because they mentioned it's a decelerations, so there's another negative in front. So have to be careful. Okay, so over here, you will get the value, which is the V minus 12.6. You will get the equation V minus 12.6 is negative 14A. That will be your first equations. Okay. Then for the 62 to 70, the time interval 62 to 70 seconds, you have a 2A is equals to, again, is a mentioned deceleration, so you need to put a negative as well. What is a gradient? The gradient is a 0 minus V over the 0 minus the V over the 70 minus the 62. So you will get the V is equals to the here 16. This is the second equation. So you just let the equation 1 equal to equation 2. Then you get V minus 12.6 is, sorry, not equal, substitutions only. So we need to put 2 into 1, 2 into 1. We get 16A minus a 12.6 is equals to negative 14A. So you get 30A is equal to 12.6. Just press your calculator. 12.6 divided by 30. 12.6 divided by 30, you can get 0.42. Okay, so this will be the answer. Done. Then we move on to the C. Find the average speed of the bus. Okay, for the whole journey. So average speed, we need to find the total area, the total distance travel. The total distance travel divided by 70 seconds. Okay. So we need to find the total distance. Total distance travel is equal to the total area under the graph. So formula, the first part is a triangle. So triangle, just now, this part we know is a 50.4 already. 50.4. So this one is 50.4. And the second part is a rectangle. Rectangle, the height is a 12.6 multiplied by the width. The width is a 40. And then the third part is a trapezium. Half times the A. This part we have a problem, okay? Because we want to find the area here. To find this area, we need to know the V. I haven't find the V yet. So we're not able to do this yet. We need to find the V first, else we're not able to get the answer. Okay. So to find the V, just now for the interval of time, that is 62. We know the A just now is a 42 already. Okay. Then we just replace it inside. We just replace it inside. Or maybe here will be better. Here will be better. V will be 16A. So I will use the interval of time 62 to 70. Or we just say that from the equation number 2, the V is equal to the 16A. Calculate it. 16A, that will give you the V is a 6.72 meter per second. Okay, so with the V here, now we are ready. So we find the total distance. Is equal to the first stage, 50.4. The second stage is a rectangle. Rectangle just now is a 12.6 multiplied 40. And the third stage is the trapezium. Half times the 12.6 plus the V. The interval time is, this interval time is 48 to 62. So just take 62 minus a 48. You get 14 seconds. Then the final stage. The final stage is a rectangle, a triangle, sorry. So it will be, the height is a 12.6. The interval time is 62 to 70. So the answer, this one is 8. The time interval is 8. So over here, just write down this formula. Just write down all of them. You're not, we need to show all of them. We're not supposed to direct get the answer. So to show all of them, then press the calculator one by one. Then you can see that the answer will be 716.52. That is your total distance travel. So your average speed is equal to the total distance travel divided by the total time taken, divided by 70 seconds. So you get the answer 10.236 meter per second. Yeah, meter per second. Or you can give me the answer 10.2. Correct the 3 significant figure. So that will be the answer for the question part C. And moving on, we have question number 4. Now we have question number 4. Two particles P and Q of masses 6 kg and 2 kg respectively lie at rest 12.5 meter apart from a rough horizontal plane. The coefficient of frictions between each particle and the plane is 0.4. Particle P is projected towards Q with a speed of 20 meter per second. Show that the speed of P immediately before the collisions with Q is 10^3 meter per second. So over here, we are having a particle P and we are having a particle Q. So the particle Q is at rest. So the P is projected with a speed of 20 meter per second. This one is 6 kg. This one is 2 kg. And the surface is rough. So we want to know that when the B reach over here, what is the V? And we need to show that the V is a 10^3. Okay, so what you need to do is we will resolve forces. Okay, so if you go resolve forces horizontally for the particle P, you have negative Fr is equal to the MA. What is the Fr? Fr is a mu R. What is the R? So to find R, if we resolve the forces for P vertically, you get the R is equal to the mg. So it's actually equal to the 60 Newton. They're giving you the mu is a 0.4. So now from here, by combining together, you have a 0.4, 60 is equal to the 6a. I don't forget the negative. So your A will be a negative 4. So you're having decelerations. Okay. Now, after we have this, then we have a v square equal to the u square plus 2as. So it will be the v square is equals to the 20 square plus the 2as. The distance from here to here, they mentioned that the distance is a 12.5 meter. So it's 12.5 meter. Okay, so your v is square root of 300. That will be 10 sub 3 shown. Okay, so this will be the speed of the P right before it hits the collide with the Q. So now, this is the collisions happen over here. After they collide, they coalesce. Coalesce means they combine together. Combine together, become R. Okay. So P and Q after collide, they become R. And then we want to find the KE loss. So by using the conservations of momentum, so we have before they collide is the mass of P, the velocity of P, plus the mass of Q, the velocity of Q is equals to, they combine together and then they share the same velocity. Okay, so maybe I call this one W. Okay, so now just use your calculator. You will get this one as a 60 sub 3 divided by 8. 60 sub 3 divided by 8 Q is actually 15 sub 3 over 2. This is the speed of R. Okay, the velocity of R, okay, after they collide, after they coalesce. Okay, so this is the first part. Then after that, we want to find the KE loss. So the total KE loss is equals to the KE at the very beginning. At the very beginning, you only have the MP. The V is 10 sub 3. Okay, then KE loss, yeah, minus the, after they coalesce. All right, now please, let me try to squeeze everything inside the line here. 6 plus 2 after they combine, and your speed is this. Okay, so this one will be 900. This one will be 675. So the total will be 225 joule. So this will be the answer for the part B. Okay, this is how you find the total KE loss. Then move on, we have a part C. Coefficient of frictions between R and the plane is still 0.4. Find the distance traveled by the particle R before it comes to rest. Okay, so now after the R combined together, now the R is actually become 8 kg already, because R is a combination of P and Q. They want to know the distance traveled. When it reach over here, it's a 0. Okay, and this speed is the speed over here just now is a 15 sub 3 over 2. Okay, so this is the U. Okay, so we need to calculate the normal contact force. Okay, the normal contact force is that the R is equal to the 80 Newton. Then your FR is equal to the mu R. So it will be equal to 32. That is your frictional force. So if you resolve the forces vertically, negative Fr is equal to the MA. Negative Fr is equals to the, actually we MA. So your 32 here, this is a A, your deceleration is still -4. Okay. Yeah, of course, what am I thinking? Your coefficient of friction is still the same. That means your deceleration will still be the same. Okay, yeah, but never mind. Okay, so we just write it down already. Then we will be having the distance travel. It just take the 0 square is equals to the 15 sub 3 over 2 square plus the 2AS. So just use your calculator, press everything. Then you can see that your answer will be 675 over 32. Okay, 675 over 32. Or you can give me the answer in decimal place, 21.1 meter. Correct the 3 significant figure. So done. This will be the answer for question number 4. Moving on, we have question number 5. Which lies on the plane inclined at an angle 40 degrees to the horizontal, and the particle B of mass 1.6 kg, which lies on the plane inclined at an angle 45 degrees to the horizontal. The particles are connected by a light inextensible string which passes over a small smooth pulley P fixed at the top of the plane. The part AB and BB of the string are taut and parallel to lines of greater slope of the respective planes. The two planes are rough with the same coefficient of friction mu between the particles and the plane. Find the value mu for which the system is in limiting equilibrium. So over here, we know that the tension for both sides are the same. This is the normal contact RA. This is the weight 12 Newton. This is the normal contact RB. This is the 16 Newton. So this one is heavier. So by right, it will going down. This one will going up, but they are still in equilibrium. Okay. So the heavier side, the frictional force, because it has a potential to go down. So the frictional force will go up. This one, because it get pulled by the string, so since the B is going down, then A has the potential to go up. That means your frictional force will go this way. So these are the forces for each of the particle. So at A, we copy the diagram here. This is the frictional force. This is the angle 40 degrees. So if you resolve it this way, you will see that your RA is equal to the 12 cos 40. Then your FA is equal to the mu A is equal to the 12 mu cos 40. I don't plan to press a calculator, okay, because just leave the answer like this, I think is enough. No need to press a calculator. I want to remain my answer as accurate as possible. So now I resolve the forces these directions. I have the T minus the FA minus the mg sine 40 is equal to 0 because it's a limiting equilibrium. So your T minus the 12 mu cos 40 is equal to the 12 sine 40. I will call this one equation 1. So now at B, sorry. So we have a tension here, and this is the normal contact. This is the weight, and your frictional force go this way. So if you resolve the forces this way, you have a RB equals to the 16 cos 50. Well, this is the 50, by the way. So if you resolve it this way, you will get T plus FB minus the 16 sine 50 is equal to 0. That means the T, your FB is a mu RB 16 sine 50. Okay, so we form the equation number 2. So to find the mu, we just need to get rid of the t, solve the simultaneous equation. To get rid of the t, just take the equation 2 minus the equation 1. Then you get 16 mu cos 50 plus the 12 mu cos 40 is equal to the 16 sine 50 minus the 12 sine 50. Factorize the mu out, then you divide them to the other side. You get 16 sine 50 minus a 12 sine 50, 12 sine 40, sorry, 12 sine 40. Divided by the 16 cos 50 plus the 12 cos 40. And now you press everything directly from the calculator. You will get the answer. The mu is a 0.233. Correct to 3 significant figure. Done. So this will be the answer for the question number 5. Okay, yeah, correct. We only need to find the mu. And moving on, we have question number 6. Question number 6. Okay, a car of mass 1,300 kg moving on a straight road on the horizontal sections of the road. The car has a constant speed of 3 meters per second, and there is a constant force of 650 Newton resisting the motions. Find in kilowatt the power developed by the engine of the car. Okay, so over here we know that the power is equal to the FV. Okay, the F is the driving force. Okay, so that means that the driving force can be rewrite it as a power divided by the V. Okay, so if you resolve the forces horizontally, you get the driving force minus the FR is equal to the MA. But you get the FD minus is equal to the FR. Why? Because you have a constant speed. So when you're having constant speed, your acceleration will be 0. So your FR resistance force is a 650 Newton, and this is the power divided by the V. Okay, because of this reason. So your P is a 30 minus 650. You get 19,500 watt, but they want it to be kilowatt. So 19.5 kW kilowatt. So this will be the answer for the 6A part 1. Now we move on to the 6A part 2. 6A part 2 is they asking you to find the instantaneous accelerations of the car. If the car suddenly the power increased by 9,000 watt or 9 kilowatt. So increased by, the word by means you just on top of what you're having here, you add another 9 kilowatt. Okay, so over here we actually just need to use back the same formula just now. The driving force, okay, the driving force minus the FR. This time suddenly, because the driving force increase, So it will have accelerations. So this will be the P over the V minus the FR is equal to the MA. So your P is a 19.5. I need to convert it to watt. We are not going to use kilowatt. So 19,500 plus a 9,000. So divided by the speed at that time is still 30 minus the 650 Newton of the resistance force and 1,300 of the mass, like this. Then you just press the calculator. You will get the answer. A is a 300 divided by 1,300. It will be 3 over 13 meter per second square. Okay, yeah. Or you can press the answer in decimal, but I think I'll just leave it as a 3 over 13 meter per second square will do. Done. That will be the answer for the part 2. Now we move on to the part B. On the sections of the road, sections of the road incline at the angles arc sine of 0.08 to the horizontal, the resistance to the motions of the car is become 1000 plus 20 V Newton when the speed of the car is V meter per second. The car traveled downward along the sections of the road at a constant speed with the engine working at 11.5 kilowatt. Find this constant speed. So they mentioned the speed is constant also. That means your acceleration will be 0. So if you, first of all, we let this become theta, 0.08. Then you will get sine theta is a 0.08. Okay. Then if you resolve the forces going down the plane, well, you're going down the plane, you're moving down. Okay. So if you're moving down, then you will have the mg sine theta plus the driving force minus the resistance force. It will be equal to the MA. Okay. So you will be having that the mg sine theta plus the FD is equal to the FR. Why? Because of constant speed. Okay. So what is your mg? Your m is a 1300. Your g is a 10. Your sine theta is a 0.08. Okay. Your driving force is a p over v. Your p this time is a 11,500 over the v is equal to the resistance force 1000 plus 20 v. Okay. So you can see that we need to multiply everyone by v. Okay, so I think I will simplify first. This and this combined together, you get 40 plus 11500 v minus a 20 v. Multiply everyone by v, you get 20 v square. I think I multiply everyone by negative 20 v. Negative v. So I get 20 v square minus a 40 v minus the 11500 equal to 0. Divide everyone by 20. You can use your calculator to factorize it. Factorize it like this. So your V is equal to 25 or your V is equal to negative 23. For the negative value, we will ignore, rejected or ignore. So therefore, your V is equal to 25 meter per second. Just like that. Done. This will be the constant speed. So these are the answer for the question number 6. And we will move on to the question number 7. We take a look at question number 7. A particle move in a straight line starting from the point O before coming to instantaneous rest at the point X. At the time t second after leaving O, the velocity v meter per second of the particle is given by the 3 stages over here. Okay, so where k is a constant, it is given that no instantaneous change in velocity at t equal to x. So t equal to x is over here. Okay, so that means when the t is equal to x, these two values will be the same. The v is still the same. It will not going to suddenly change the velocity. Okay, so stage 2. I call this one stage 1. I call this one stage 2. And I call this one stage 3. Okay, so stage 2. From here. So when the t is equal to x, okay, so you will get the v is equal to the 30.6 minus the 0.9 multiplied by 8. Press the calculator, you get 23.4. Then at this stage 3, when the t is equal to x, you get the v is equal to the 1600 divided by x squared plus the k. So you have they are the same. These two value is supposed to be 23.4. So it will be just using the value. Okay, 1600. Maybe I call this one equation 1. I call this one equation 2. So E1 is equal to 2. So you get 23.4 is equal to 64 plus 8k. So from here you can find your k. Your k will be a negative 0.2. K is a negative 0.2. So once we found the k, we want to find the distance OX. OX is until you have instantaneous rest. Instantaneous rest. So over here, we know that your V cannot equal to 0. Over here, your stage 2, when your V equal to 0, your 30.6 minus the 0.9 t equal to 0. Actually, your t is quite big. Let me check. 30.6 divided by 0.9. 34. So that means this one also the V cannot be 0. The only possibility that the V equal to 0 will be happen at the third stage. Okay, so this is something you need to know. But the questions seems like the question didn't require you to check when it will become instantaneous rest at which stage. So actually we direct assume that it will instantaneous rest at the third stage. So means we want to find the total distance, means we want to find the integrations. Okay, we use integration to find the, so I take the stage 1. Distance S1 is you integrate 7.2 t squared. 0 to 2, 7.2 t squared dt. This one is easy. Integrate, you get 7.2 t cubed over 3. From 0 to 2, direct, you will get the answer as 2.4, 2 cubed minus a 0, and you get 19.2. Then stage 2, S2, it will be integrate from 2 to 8. The 30.6 minus the 0.9 t dt, also 30.60 minus the 0.45 t squared from 2 to 8. Just substitute the value inside. You get 216 minus the 59.4. then you get this as the 156.6. That is a stage 2. And then the stage 3, S3 is equal to integrate 8 until till where? So the stage 3 got a problem. We need to make the V equal to 0. So it will give you 0 is equal to the 1600 t square minus the 0.2 t equal to 0. So you need to solve it. So your t is actually equals to 20. Okay. So now our S3 will be equals to integrate 8 to 20 for the 1600 t square minus the 0.2 t. Okay. So you will be having negative 1600 over t minus the 0.1 t square from 8 to 20. Just like that. And then you press the calculator, you get negative 80 minus the 40 minus the negative 200 divided by negative minus the negative 6.4. Press the calculator, you get 86.4. So therefore, OX is equal to S1 plus S2 plus S3 is equals to 19.2 plus the 262.2. Just now S2 was 156.6, sorry, 156.6. The last one is the 86.4, 156.6. So add all together, you get the answer as 262.2. So that will be the distance of OX. Okay, done. This will be the last question for this paper. I'll see you next time. Bye-bye.